Hello everyone, Niemeyer here from the Wolves team. I hope you're doing okay. This video is going to go into what volume is and how to calculate it. So let's go ahead and dive right in. First we need to define what volume is. So you might first think that it's how loud something is. But in math, in geometry, we define volume as the amount of 3D or three-dimensional space an object takes up. But before we dive into calculating stuff with 3 dimensions, we need to make sure we are spot on with calculating for 2 dimensions, which is area. So let's take a look at these 3 shapes. We have a rectangle, a triangle, and a circle. Pause the video right now and see if you can come up with how you calculate the area for each one of these shapes. All right, let's check. So, for a rectangle, we have the area is, did you say length times width? If so, well done. Here's your width, here's your length. That's how you find the area of a rectangle. Now how about a triangle? That one's pretty similar. Did you come up with 1/2 times length times width? Awesome. So, notice that these have the same exact dimensions. The reason this one is multiplied by 1/2 is because this triangle is actually half of the rectangle with the same dimensions. So when we calculate length times width, we want to make sure that we cut that number in half, whatever we get, because we are not finding the area of a rectangle here. We are finding the area of a triangle, which is half of a rectangle. Let's take a look at the circle. What is the area of a circle? How do you find that? Did you get pi r squared? Pi times r squared, pi r squared. If so, you are absolutely correct. Now pi, for your intents and purposes, you can think of it as 3.14. So whenever you see this symbol, what's that? That's pi, it's 3.14. It is the ratio of a circle's circumference to its diameter. Now how about r? What does r stand for? It is the radius. Now the radius is what? The radius is going to be the distance from the center of a circle to the outside. So let's go ahead and move on from here. If you had trouble with any of this area stuff, make sure you go back and look at those videos that talk about area before you move on to volume. Now for this first shape, we have a rectangle. So what does a rectangle look like as a 3D figure? Well, it looks exactly the same as that 2D drawing, but I am adding another dimension of height. So you'll notice the width and the length are the same. That gets you that area of the rectangle. But now we have to accommodate for this height. So how do we do that? Well, first we need to identify that this is the base. An example is this tissue box. Okay? Here's a rectangle. That's going to be our base. How do we know it's the base? Because on the other side, it's the exact same shape. In fact, this has quite a few different bases you could use. You could use this one as your base. You could use this one as your base. Doesn't matter as long as you're consistent with which rectangle you're using. I'm going to use this one. That means this would be the width, this would be the length, and then the height would be this. 3 dimensions. So how do we calculate that? Well, here's an example of a single rectangle. Here's a Hershey's bar. You may notice it has a width of 2 Hershey's and a length of 2 Hershey's and a width of 4 Hershey's. So if the width is 4 and the length is 2, based on that formula, 4 times 2 is 8. There are 8 Hershey's pieces here. Now, we're going to pretend that this is perfectly flat. It's 2D. And then we are going to add a height to this. So I have a bunch of rectangles of that same area. See, they're all 2 by 4. They all have 8 pieces there. we're going to stack them. We're going to give them another dimension of height. I have 1, 2, 3, 4, 5, and 6. So, when they're stacked together, it starts to look more like that block figure, right? That's because we've added a new dimension of height here. So, if one of these is 8 Hershey's Pieces, and I have 6 of those stacked, how many Hershey's Pieces are there in total? Did you get 48? If you did, awesome. Here's how you do that for any rectangular prism. What you do is you take the width times the length, right? That's how we got the base area of that rectangle, and we multiply it by the height. So the formula for volume is going to be width times length times height. All right, let's take a look at the triangle. Now, what does the triangle look like as a 3D figure? Well, it's going to look kind of like a ramp. So something along the lines of that. So an example that you could use to kind of visualize this is something like a binder. Do you see how there is a triangle here and it extends along that way to kind of make like a ramp, right? Kind of looks like this. It's not as steep as the one I have here, but it is a triangular prism. Okay, how do we calculate the volume there? Well, first we need to identify what our base is. Our base is the triangle. How do I know that? Well, because if I see this triangle here and I flip it around to the other side, I have that exact same triangle. Okay, so let's go ahead and calculate that area for a rectangle. I have here some Hershey's Pieces that have been cut into triangles. They had the same dimensions as before. Width of 2, or excuse me, I mixed that up. Width of 2 Hershey's and a length of 4 Hershey's. So, because this is half of a rectangle, we know that 2 times 4 is 8, and then times a half gets an area of 4. So if we want to make this into a prism, we're going to pretend that's 2D. We're going to pretend that it doesn't have any height at all, but we are going to keep stacking that same shape, that same area on top. I'm going to do 4 this time, and then you can see it kind of makes like a 3D ramp, kind of like what it looks like here. So how do you calculate the volume here? Well, again, it's the same strategy. We take the area of the base, which is our triangle. There's my marker. So that's going to be volume equals 1/2 times length times width, right? We're finding the area of just the triangle, and then in this case, I would multiply by 4 because it is 4 Hershey's Pieces high, right? 4 triangles. 1, 2, 3, 4. So we did the exact same thing as what we did here. We take the area formula and we multiply it by its height. So now we have 1/2 times length times width times height. Here's your width, here's your length, here's your height. And then lastly, we have a circle as a 3-dimensional figure, which is going to be a cylinder. So kind of like a tube. Something like that. Okay. So an example here is like this can of olives. Now you'll notice that the circle must be the base because if I flip it over to the other side, it's that exact same area. It's that exact same circle. So we're going to do the same kind of strategy. We are going to calculate the area of the base, the area of the circle. So that's going to be volume equals pi r squared, pi times r squared, and that's going to be the area formula right here. But you might have noticed a pattern. It's the area formula times the height. Area formula times the height. Can you guess what's going to happen here? Yes, we are adding, or excuse me, we are going to multiply by h. We're adding in a dimension of height. So an example could be like if we pretend that this cookie is perfectly flat. And we find the area of this. Let's say the area of this cookie is 2. We're going to add a dimension of height to it. 1, 2, 3, 4. If there are 4 cookies here and the area of 1 is 2, well then we would take the area of that circle, which in this case is 2, and multiply by the height we just created, which was 4. So, if that confuses you about the whole stacking thing, all you really need here is to know that to find the volume, you need to take the area of the base and multiply it by the height. Let's go ahead and do some practice problems with this. I hope you guys are staying busy, staying healthy, doing anything fun. All right. Let's go ahead and start with the prism here. I'm going to do it in blue because why not? Here's your block. We are going to say that the length is, I don't know, let's do 10. We're going to say the width is going to be 4. And we'll say that the height is 3. How do you calculate the volume? Pause the video now and see if you can calculate it on your own. All right, let's check. Let's add some units to these just because Hershey's Pieces isn't really a good unit. So typically we use units of length like inches or feet. So let's do 4 inches, 10 inches, and 3 inches. Well, first we need to find width times length, or the area of this rectangle here. Did you get 40? 4 inches times 10 inches. So 4 times 10. And then we just need to multiply by that last dimension of 3. 4 times 10 is 40, and 40 times 3 is going to be 120. Now, what are the units going to be? Well, we used inches as our measurement. But if I leave it as 120 inches, that doesn't make much sense because that's a unit of length, and we're talking about 3D space. So whenever you calculate volume, your units are always going to be whatever was in your problem, or cubed with that little 3 up there. Okay, let's move on to a triangular prism one. All right, so that looks kind of like a ramp. Something like this. Okay. What's our base shape on here? That's the triangle, right? So we need to find the area of that first. So let's do 3 feet, 3 feet, and 4 feet. What is the volume of this prism? Try it now. Okay, let's check. So, based on our formula here, we have 1/2. Why 1/2? Well, because it's a triangle, so we got to cut that in half, times the length. Well, the length is 3. The width is also 3. That gets us the area of this triangle. But remember, we also need to multiply by the height. The height is going to be 4. So let's see. 1/2 times 3 is like 1.5. Ooh, maybe it'd be easier if I did 1/2 times 4 first. 1/2 times 4, well, half of 4 is 2. 2 times 3 is 6. And then 6 times another 3 gets us 18. 18 what? We used feet. And because it's volume, we are going to make it cubed. Feet cubed. All right, let's take a look at that last one there. We are going to do a cylinder practice problem. Okay, here is our cylinder. And let's see, let's make this 8 let's do 8 centimeters. And then let's make this distance, here 4 centimeters. Take a look at our formula here. First, we gotta include pi, always gotta include pi. And then I'm gonna multiply it by r squared, that's the radius squared. Now be careful here, what's your radius? He said 4, double check. This 4 represents the whole distance from one side of the circle to the other. That is called the diameter, which is twice as long as the radius. So if the diameter is 4 centimeters, how long would the radius be? Yeah, it should be 2. So let's change this because we really don't care about the diameter. We want to know the radius. It's going to be 2 centimeters. Well, we have 2 as our radius. It's going to be squared. And then we multiply by what? Yeah, the height, which in this case is going to be 8. Okay, now we just need to simplify this. Start with the radius squared. Remember, exponents comes first in order of operations. So 2 squared is going to be 2 2's multiplied together, or 2 times 2. So that's 4 times 8. Now from here, we can do 4 times 8, and that gets us 32. And you can just go ahead and do 32 pi. That's fine. If you want to plug in 3.14 and calculate like a decimal of this, it'd probably be around the range of 100 as a decimal. You're welcome to do that, but I'm just going to keep it as 32 pi. But I want to make sure that I throw on that we were measuring in centimeters. And we don't want to just put centimeters. We're talking about volume, so it needs to be centimeters cubed. All right, you guys, if any of this you have any questions about, feel free to email me or talk to your teacher. Go ahead and take a look at the problems on Google Classroom and test your skills. All right, till next time.